Hi, everybody. Trevor Galbraith here with the latest of our Tech Talk podcasts. If you like this podcast, don't forget to subscribe and like it by ringing the bell below. Now, let's get started with the very first of our Rising Star interviews. Adam Klett is one of a new breed of young, energetic engineering scientists who has recently joined the electronics manufacturing community. His passion lies in pushing the boundaries of technology and science to deliver cutting-edge solutions that meet the highest industry standards. At IPC Apex Expo this March, Adam's going to be joining our lineup of rising stars who's going to be hosting a series of in-depth panel discussions. We'll be talking to Adam today about his work and what we can expect to hear from him at Apex.
Welcome to Tech Talk with Trevor Galbraith, a video podcast that features industry leaders and experts from the electronics manufacturing community. Recorded at major events around the world and from the studios of Global SMT TV. Now here is your host, Trevor Galbraith.
And welcome, Adam. Nice to see you today. Thank you for coming in. Okay. So, just to sort of set the stage, I mean, you're a relatively newcomer because within the last 12 months. To the industry. So what attracted you to the EMS industry? I mean, presumably as a chemist, you could have gone anywhere. So why the electronics industry?
That's a good question. So I am relatively new to Kyzen. I started about 18 months ago here as our director of science. But before that, I was an engineer in a materials and processes lab where I supported the manufacturing of electronic assembly. So I'm not quite, I was there for about 6 to 7 years before starting this position here. So I've always been interested in tech as a kid. I was always taking apart stuff and, getting into trouble. And so, it's something that I'm very interested in. I got my degree in engineering for that reason. And I really enjoy the work that I'm doing here at Kyzen.
Okay. So you got a stream of broken toys at home somewhere.
I should have picked up on that too. So.
Okay, so let's look at the work that you do at Kyzen. Maybe you can tell me what your approach is to when you help customers design and qualify a cleaning regime for new products. Now, I know your predecessor very well. I know the way he did it. So maybe you can elaborate from there.
Yeah, of course. So it really depends on where the customer is starting, right? So if they already have a manufacturing line, they've already set up, their chemistry choices and all of that. They're just making a new board, right? That's probably the easiest scenario, right? Because a lot of the problems that might come across these days are going to be with new components, whether they have denser boards or lower standoff components. And a lot of the optimization is just going to be in tuning the process parameters within a process that already exists. Right? There's not going to be a whole lot of change on the line itself. Now, if you're talking about a customer who is brand new, they want to start up a new line, they're adding a line to their facility, that's a different question. There's a lot more that goes into that. There's a lot of machine questions that we necessarily can't answer, but we can support. For example, there's things like how many boards you want to put through your process or how big the boards are, right? Depending on those types of questions, you might want to go with maybe an inline or a batch cleaner. So we can support those steps. And then kind of parallel to that, there should also be consideration to what chemistry you're going to choose. That is going to be largely affected by what you're trying to clean and what you're trying to clean off of it, right? So there's a lot of material compatibility concerns that go into that. Obviously, we want to make sure that we remove the soils, but not destroy what's already on the board, right? It's like selective removal. So that's always something that's taken into account. And then once those big decisions are made, we have a process, we have chemistry. Then we can go into the optimizing the parameters of that process. Things like, belt feed, temperature, nozzle selection, nozzle configuration, those types of parameters.
Right. Yeah, I mean, there's a lot of change happening in the industry in terms of materials coming in. There's all this heterogeneous materials and trying to get chiplets to work together. So, you have to, as you said, be able to find something that's going to clean the soils without damaging some of these more sensitive materials. Um,
Exactly.
yeah. But so I mean, looking at the whether a customer's got a batch cleaner or an inline cleaner, I mean, do you find one more effective than the other?
It depends on the process. So they can, but they both have their benefits and their downsides. The inline cleaner, if it has a higher throughput, and it's able to clean some things better, some soils better. The biggest advantage of the batch cleaner is the fact that it has such a small footprint, and the timing, the scheduling can work better for some customers. It's kind of like a set it and forget it, as opposed to having a constant throughput where you have to have an operator on one end of the line and the other kind of deal. So they both have their own benefits. As far as cleaning is concerned, though, it really depends on the soils themselves. They both have their benefits, and that's part of the reason why we have to go through that process with our customers, depending on the soil that they're cleaning, and the size of the boards, and what other process parameters that are affected. Like for example, in a batch cleaner, you might have more shadowing effects that can occur if you fill the batch, if you fill the tray too heavily, or if there are things that get in the way. You don't necessarily have that problem as much with an inline cleaner, although if you have something in a fixture or a cage, that might also cause those similar types of issues. But
Right.
like I think the question, there's no clear winner that is generally applicable across all cases.
Right. Right. Okay. But I mean, I would imagine it's fairly important, especially in the inline system, to make sure that you're monitoring that bath regularly, and use
Oh,
all
of course.
these systems that you brought out to make sure that it's
Mhm.
the the concentrate or whatever it is you're using, uh,
Mhm.
keeping the right level of cleaning and
Correct. Yeah. So the chemistries are designed to operate within a specific concentration range, and if you're outside of that range, then bad things might happen. So if you're too high, right, then you're essentially wasting chemistry. You're spending money on something that doesn't need it. It there might be material compatibility issues if you get too high of a concentration. That's normally not the case. A lot of the issues start to come across when you enter the low concentration end. If the concentration starts to dip below a certain level, then it doesn't clean as effectively. And as you mentioned, we do provide ways to control that. There are manual methods that we can support, but then there are also automated methods that are much easier. They require less attention from the operators, and they do a very good job of maintaining that level exactly where you program it to be.
okay, great. So let's turn our attention now to how you perform failure analysis on field failures. Um,
Mhm.
let's say, do you have a certain methodology that you go through when you get something like that coming into your lab?
We do, yeah. And so it depends on the type of failure. So from us, a lot of times we'll have customers that put boards or components through their cleaners, and either maybe something pops off, or something like an ink comes off, or that something starts to swell or get laminated, or maybe something on the board doesn't look right. There's spots or things like that. And so we have a process for deciding whether or not that's a mechanical failure, or like a chemical failure, or maybe it's somewhere in between. Like for example, if an ink is coming off, maybe the jets are too high of a pressure, but that could also be a chemical incompatibility that we have to address. That can be, and then in solving those issues, also can involve an array of um, potential. Uh, we'll say um, solutions. Like for example, we can go from changing the parameters of the cleaning process. So either like say reduce your temperature if you can, or increase the belt speed, or mechanical stops or physical barriers. Let's say you have a component that not needing to be cleaned, it's just present, uh, but it's being affected by the cleaner. So we can add like maybe a cap or something to it. There are lots of different solutions to the variety of problems that we could come across.
Yeah.
Those are the the cleaning problems that one might get once they pass something through and it comes out the other end. But then there's problems that maybe it comes out the end of the cleaner and it looks fine, but then it goes into some sort of functional testing and it fails, like an electrical test or something like that. And for those kind of tests, we have an array of electrical things that we can do, or in an analytical lab, they can look for different types of contaminants that might be causing those types of problems. IC testing, Rose testing, SIR testing to do that type of troubleshooting to understand the root cause of like a functional failure.
Okay. All right. Now, as I mentioned earlier, I mean, there's an array of new materials coming into the industry. There's new substrates coming in, silicon carbide, glass, etc. What new cleaning materials are you bringing out for the ultra-sensitive advanced packaging applications?
So we have a line of chemistries that are specifically designed to meet those very strict material compatibility applications in the advanced packaging and semiconductor field. There are a lot of issues with oxidation, or metal removal completely, right? So a lot of cleaners or traditional cleaners may have completely oxidized or removed those finishes that are very essential for the functionality of those parts. And so we've had to adjust our formulations to make sure that we can still clean the residues, the flux residues and things like that, while maintaining the chemical compatibility concerns. Uh,
Okay. I noticed actually, I think it was this week, you brought out another chemistry for cleaning bonding wires and things like that, which is quite different. That's a new area that you seem to be getting more involved in. Now, we're very excited to know that you're going to be joining us in our live studio at Apex this year. And you've got a couple of panels coming up that you're going to be hosting. So let's talk a little bit about these. I think the first one is going to be on Tuesday at 10 o'clock Pacific time. So if anybody's interested in joining Adam for that one, the topic is cleaning and no clean fluxes. Cleaning no clean fluxes, should I say. Talk us through a little bit about what you are expecting to discuss in that. And I don't know if you know any of your panelists yet, but if you do, then maybe you can tell us who they are.
Okay. The panelists haven't been completely decided yet, set in stone. But what I'm trying to do is I'm trying to find a good mix of users and suppliers for that, because I'd like to get both sides of the story, if you will. But the topic of cleaning no clean fluxes comes up a lot. I've gotten questions everywhere from, "Hey, it says no clean. Why are we cleaning this?" To technical questions on actually how to do it. Um, there is a lot of confusion about why you might want to clean a no clean flux. We have our panel that's going to discuss why you might want to clean a no clean flux, is the consequences of not cleaning a no clean flux, or even worse, like partially cleaning a no clean flux. Right, so there are certain downsides to each of those. And so making sure that our customers are aware of the consequences of certain levels of cleaning, right? So in some cases, we say it's better to not clean at all than to partially clean, due to certain properties of those no clean fluxes. And that's something that we'll dive into during the panel. The other thing is how to clean no clean fluxes. No clean fluxes are typically designed to not be cleaned. But they also need to be benign. The manufacturers recognize that there are certain components within the fluxes that can cause corrosion, electrochemical failure, things like that. All right, and so they'll design these to be resistant to that. But by doing that, by kind of creating this protective layer that keeps the maybe unactivated flux residues or things like that kind of separated from the rest of the circuitry, makes it very difficult to clean, right? And so there are certain reasons or certain methods for cleaning no-clean fluxes that are different than cleaning water-soluble fluxes. It's a little more difficult. So we're going to have our users and suppliers talk about why it's more difficult. First of all, kind of go a little more detail about what I just explained, and the how to actually go about doing that.
Right, that's going to be kind of interesting. So, no clean fluxes doesn't mean that you don't have to clean it.
Correct.
The other one that you're going to be talking about is on Wednesday, and that's on Understencil Wipe Cleaning. What's going to be the key highlights of that one?
The key highlights. So that one, the panel has been decided for that one. We're going to have a Debbie Carboni from Kyzen. We have Anna Lifton and Chris Shea are going to be joining me. And we're going to be talking about the importance of understencil wiping. And what I mean by that is the wiping process that happens during the stencil printing process when solder paste is applied to the board. There's a lot of people that say that any issues that happen during that stencil printing process kind of cascade down the line and will cause lots of failures. I've heard numbers anywhere from 50 to 90% of the errors either occur or could be presented by issues that occurred during that step. And so one of the biggest things that you can do to fix stencil printing issues is to clean the underside of that stencil every so often to make sure that you're not getting things like poor transfer efficiency, you don't get residues that contaminate the board. And there are a handful of things that can happen if you don't do that underfill or that understencil wipe. And so, like I said, I'm excited to have those three panelists that I just mentioned on the discussion to talk about, one, what can potentially happen if you don't, do an understencil wipe, and two, the best ways to do that. Right. So, for example, Debbie Carboni, I think, is going to be presenting a paper on understencil wiping at Apex this year when she's going to be talking about different methods, different programs for wiping, why you should use a certain amount of liquid, how often you should be doing them, should or should you not use a vacuum step within that method. And so there are a lot of technical details that people need to be aware of to help them get the most optimum stencil printing process.
Right. Well, certainly sounds like you've got the right lineup there for sure. Debbie and Chris Shea, and so make sure tune in for that. So looking forward to it. I believe before you get to Anaheim this month, in March, you're to PanPack next week. Is that right?
I will be at PanPack next week. I'm excited.
Yeah, that's going to be quite a trip for you. So enjoy the trip to PanPack. It's always a high level conference for sure. So look forward to that, and we look forward to seeing you in Anaheim in March.
Well, thank you very much. I appreciate it.
Okay, thanks for joining us today, Adam.